Hello everyone, we are solving problems on the Thevenin and Norton theorem. In that, next question is ideal voltage source in parallel with ideal current source.
Options are option A, both Thevenin and Norton exist. Option B, neither Thevenin nor Norton exist. Option C, Thevenin exist but Norton not exist. Option D, Thevenin not exist but Norton exist.
In the given question, what he is asking, ideal voltage source is connected in parallel with ideal current source. So if you observe here, this is open circuit. So what is the open circuit voltage? VOC is equal to VThevenin. So what is VThevenin? This voltage, okay, these two are connected in parallel, so voltage across these two sources are same, so VOC is equal to VThevenin equal to V. Now to find Norton current, so replace short circuit. If you replace short circuit, what will happen? So the voltage, the ideal voltage source is short circuit, okay, this will never happen, so the Norton current is not exist, okay, we should not replace the short circuit across voltage source because the current is infinity. So the current flowing through the source is infinite because the resistance of this short circuit is 0. So I is equal to V by R. V by R means V by 0. So it is infinity. So it is not exist. So Norton current is not exist. Only Thevenin voltage exist. Now to find Thevenin resistance, so replace voltage source with short circuit and replace current source with open circuit. So what is R Thevenin now? Short circuit. Short circuit means 0 volts. So what is Thevenin equivalent? Okay, this is the Thevenin equivalent. So what is option? Option C is correct. Thevenin equivalent is exist. So R Thevenin is 0 here, short circuit. Thevenin equivalent is exist but not Norton is exist. Next question is ideal current source is in series with ideal voltage source.
Options are option A, both Thevenin and Norton exist. Option B, neither Thevenin nor Norton exist. Option C, Thevenin exist but Norton not exist. Option D, Thevenin not exist but Norton exist.
If ideal current source is connected in series with ideal voltage source, what will happen? So what is the open circuit voltage? VOC is equal to VThevenin. So by KVL, the voltage across this source is V. But we don't know the voltage across this current source. So open circuit voltage does not exist. That is, we don't know the VThevenin exactly. This Thevenin voltage depends on the voltage across current source. We don't know the voltage across current source. So Thevenin voltage is not exist. Now replace short circuit here. So what is ISC? ISC is equal to same current is flowing through entire circuit, that is these all are in series, so ISC is equal to I. So this is I Norton. Now find Norton impedance. So replace voltage source with short circuit and replace current source with open circuit. So what is R Norton now? R Norton is equal to open circuit. Open circuit means infinity. So what is Norton equivalent? So this is Norton equivalent. So what is option? Option D is correct. Thevenin is not exist but Norton is exist. Next question is determine VOC and ISC for the network shown in the figure across terminals AB. Okay, this is the given network. So what he is asking? VOC. So what is VOC? Voltage, open circuit voltage. These three elements are connected in parallel. So same voltage across these two terminals. Same voltage appear across these two terminals. So VAB is equal to VOC is equal to 10 volts. Next ISC. So if you replace short circuit, so what is the current flowing through this short circuit? So this voltage source is short circuit. So voltage source should not short circuit. So ISC becomes infinity. This is never exist. So only VOC 10 volts and ISC is not exist. Next question is determine ISC and VOC for the following network across terminals AB. This is the given network. So what he is asking? Determine ISC and VOC. So what is VOC now? If you apply KVL, the VOC, the voltage across this voltage source is 100 volts. So voltage across this 20 ohms is, this is plus, this is minus. Okay, current entry here. So 5 into 20 means 100 volts. But we don't know the voltage across current source. Okay, by KVL, summation of algebraic sum of all these sources, all these voltages, but we don't know the exact voltage across current source. So this voltage depends on these two parameters. So VOCs cannot be determined. Now find ISC. Replace short circuit here. Now what is ISC? So the entire branch current is 5 amps. So what is ISC? ISC is equal to 5 amps. Next question is, the network shown in the figure acts as ideal voltage source when the frequency of oscillations is. Options are option A 0 radians per second, option B 1 radians per second, option C 2 radians per second, option D 4 radians per second. Okay, this is the given network. This circuit acts like a ideal voltage source. Ideal voltage source means voltage source in series with zero impedance. Okay, this is zero impedance. Zero impedance means short circuit. So when this impedance is zero from this network, okay, first find the Thevenin impedance. Okay, this is open circuit. From this find Thevenin impedance. How to find Thevenin impedance? First find the impedance for inductor. So ZL is equal to, formula for inductor is, impedance of inductor is J omega L. So here L is 1 by 16. So J omega by 16 ohms. Next, ZC, impedance of capacitor. Formula for impedance of capacitor is 1 by J omega C. So C is 1 farad. If I bring this J from denominator to numerator, it will becomes minus J by omega. Okay. Now, how to find Z Thevenin? Replace voltage source with short circuit and find open circuit impedance. Then it will become Thevenin impedance. This is the circuit. Here, two impedances are connected in parallel. Okay, this is ZL and this is ZC. So both ZL and ZC are connected in parallel. So what is the Thevenin impedance? ZL ZC by ZL plus ZC. So what is ZL? So this is plus J omega by 16 into minus J by omega divided by J omega by 16 minus J by omega. So you will get Z Thevenin is equal to, so here J omega get cancelled. Sorry, omega gets cancelled. So J into J, J square, minus J square means plus 1. So omega by, you will get, if you solve this, you will get omega by J into omega square minus 16. Okay, when this impedance becomes 0, if numerator becomes 0, then total impedance becomes 0. So what is numerator? Omega is equal to 0. Okay, so what is option? Option A is correct answer. If omega equal to 0 radians per second, then the circuit becomes, or the network becomes ideal voltage source. Ideal voltage source means voltage source in series with short circuit. For suppose, for same question, if ideal current source, okay, if circuit becomes like ideal current source, so ideal current source means current source in parallel with open circuit. Okay, current source in parallel with open circuit. Open circuit means infinity. When this impedance becomes infinity, if denominator is 0, then impedance is infinity. If denominator is 0 means omega square minus 16 equal to 0. If this becomes 0, this entire term becomes infinity. So from this, what is omega? 4 radians per second. With this, case 1 problems are completed. In the next video, we will start case 2 problems. Thank you for watching.